Yeah, good evening everyone. Good evening everyone. Good evening. Yeah, I think we can start. We can start the today's session. Let me start this. I'm starting this. GATE 27, 28 people. GATE 27, 28 people. Right? We are starting discrete mathematics. So in that topic is permutations and combinations. So this is the topic. Permutations and combinations we are starting. Right, so I'm starting now. So let's see the first one. So let me write the name. Permutations and combinations. I'm writing. Yeah, so today's date is, I think, 8th. Yeah, 8th, I think so. 8 1 25 26 na. Yeah, 8 1 26. Permutations and combinations we are starting 8 1 26. This is for 2027 people, 28 people. Right, so yeah, so now let me share the screen. Everything is perfect. Now let me share it. Yeah, so this is the starting of today's class. Permutations and combinations we are starting 8 1 26 date. And one more thing I want to say to you, this is meant for 2027-28 discrete mathematics permutations and combinations we are starting. And 60% offer is going on. Whoever is interested, they can take the course. 60% discount going on. So right, 1 year course, right, regular course you can take. 1 year purpose regular course. This is the 1 year. 2 year foundation course you can take. 1 year is regular course, 2 years is foundation course. Right, so permutations combinations we are starting. Right, let me try one by one. Let me try. So I hope audio video everything is perfect. This is the starting of the today's class. This is the starting of the today's class. Permutations and combinations, date also written. Now let me write the first story. Let me write first. Careful everyone. First topic is product rule and sum rule. First topic is product rule and sum rule. So what is that? We'll see some problems on that. Permutations and combinations. So product rule, sum rule. We will do some problems on this. So everything is ready. Everything is ready. I'm doing. So please take care. Let me know little doubt also. Product rule, sum rule we are discussing. Right? Let's see the first problem. Let's see the first problem. I'm writing the first problem. Careful. I'm writing the first problem. So let me write the common data first. Common data. Let us assume that it is Delhi. It is Delhi. It is Bangalore. It is Bhopal. It is Mumbai. Don't worry about direction. Don't worry about direction. Let us in the Delhi to Bangalore. To go Delhi to Bangalore, let us assume that three ways are there. To go from Delhi to Bangalore, three ways are there. To go to Bangalore to Mumbai, let us assume five ways are there. Next one, to go to Delhi to Bhopal, assume four ways. To go to Bhopal to Mumbai, assume six ways. Right? Perfect. This is the diagram. This is the diagram, right? Everyone listen, right? So the first thing what we are going to discuss is product rule, sum rule. This is the thing which we are going to discuss. Everyone know, but it is my responsibility to say I am saying this. Product rule and sum rule. Permutations and combinations. So that is the topic. Product rule, sum rule we are discussing. For that, this is the data. Right? Now let me write the first problem. Make sure everyone will get it. Make sure everyone will get it. See the first problem. Question number 1 I am writing. How many ways? How many ways possible? How many ways possible? How many ways possible to go from Delhi to Mumbai via Bangalore? This is the first problem. Let's try how many people will give answer. How many ways possible to go from Delhi to Mumbai via Bangalore? This is the diagram. This is the diagram. This is the diagram. Right? By seeing that diagram, please give answer. How many ways possible to go from Delhi to Mumbai? How many ways are there to go from Delhi to Mumbai via Bangalore? I'm expecting answer. Whoever is watching, please let me know what is the answer for this. Everyone can try this. Someone is saying, is this for GATE 2026? No, it is a GATE 2027. Because it unnecessarily it will waste your time. 2026 people, right? I don't think you have to watch this. I don't think you have to watch this. It is for 2027 people, 28 people. 27, 28. Yeah, I'm repeating once again. Topic is permutations and combinations. Remember, everyone. I am saying now. In my opinion, class is just started now. This is for 2027 people, 28 people. Topic is permutations and combinations. Date is 8/1/26. So now we are discussing about product rule and sum rule. In the permutations and combinations, the first topic is product rule, sum rule. First topic is product rule and sum rule. So I written one diagram. I drawn one diagram. In the diagram, right, based on that diagram, so I written the one problem. How many ways possible to go from Delhi to Mumbai via Bangalore? Can you give the answer for this? Can you give the answer for this? Everyone try. How many ways possible to go from Delhi to Mumbai via Bangalore? Everyone can try this. Everyone can try. And one more thing for your convenience, I'm writing one more problem also. Similar problem I'm writing. Two. Question number two. Question number two also let me write. How many ways possible? How many ways possible to go from? How many ways are there to go from Delhi to Mumbai? Delhi to Mumbai via Bhopal. These are the two questions. I think if you can give the question number 1 answer, question number 2 answer also you can give. Both are similar. The purpose of this problem is I want to explain first topic, product rule and sum rule. I want to explain product rule and sum rule. I want to explain product rule, sum rule. So can you go there? Can you go ahead? How many ways possible to go from Delhi to Mumbai via Bangalore? That is the question number 1. How many ways possible to go from Delhi to Mumbai via Bhopal? That is the question number 2. Please, can you go ahead? Everyone try. I think if you observe clearly, right, to go from Delhi to Mumbai via Bangalore. Bangalore means I think upper one you can think about. So here 3 possibilities are there. Out of these 3, select one, 3C1. Next one, right, I think Bangalore to Mumbai, I think here 5 ways are there. 5 out of 5, select one way, 5C1. But remember, right, so Delhi to Bangalore and Bangalore to Mumbai, no relation at all. No relationship. But one after another. Linking is there, one after another. Right? There is, see this one, continuation only. Delhi to Mumbai via Bangalore. You are on the way, but left one, right one, most probably there is no relation. Left one is individual entity, and right one, but combinedly there is some work. It is very difficult to identify when to apply sum rule, when to apply product rule. Very difficult to explain. But you have to use common sense. Can I apply sum rule here or not? Can I apply product rule here or not? You have to check properly. Remember, it's one path you are doing. It's a one path. In that path, there are 2 parts are there. It is almost like the for loop is going on. Inner for loop. I value 1, J loop. For right inside the I loop, there is a J loop. Inside I loop, there is a J loop. Inner loops. So whenever something like inner loop, what is the meaning of inner loop? Each I value J will rotate. I is equal to 1, J is going on from 1 to n. I is equal to 2, J is going on from 1 to, right, J is going on from 1 to n. So this is called something like product rule. Inner loops are nothing but a product rule. It is almost like that. So to go from Delhi to Mumbai, one way is Delhi to Bangalore you go, Bangalore to Mumbai. He's saying that via Bangalore. That is the reason I'm trying Bangalore. So Delhi to Bangalore, I think 3 possibilities. Out of them, select one. There are 3 ways. Bangalore to Mumbai, out of 5 ways, select one way. There are 5 ways are there, 5C1. But remember everyone, right? So, right, I think if you observe clearly, 3C1 and 5C1. Continuation is there, that's okay. But in the 3C1 and 5C1, there is no relation at all. Continuation is there. So out of 3, select one. Out of 5, select one. I think if you see the total possibilities, 3C1, which is going to be, if you want, I will give the names also, so that you will get the clarity. A, B, C. Don't try permutations and combinations. Some people are asking, sir, I want to apply blindly formulas, sir. I want to apply blindly formulas only. Can I apply permutations and combination? It's impossible. Permutations and combination chapter saying that brain needed, common sense needed. Formulas cannot work. I cannot say blindly apply product rule here. I cannot say blindly apply sum rule here. You have to use common sense. Not only permutations and combinations, in the total computer science, without using common sense, you cannot do anything. You cannot get those people who are getting the negative marking in the GATE examination, those people who are getting less marks in the GATE examination. The reason is you are trying computer science, right, to by heart. You are applying some formulas in the computer science. If you use common sense in the computer science GATE examination or computer science competitive exam or computer science interviews, most of the interviews you will crack if you use common sense. If you start by hearting, I think computer science branch is going to be very difficult. By applying simply formulas cannot work here. So careful. So I think out of A, B, C, select one way. Next one, I think A, B, C, D, E, F, G, and H. Right? So now see the answer. Out of 3, select one, 3C1. Next one, out of 5 select one, 5 C1, but remember it is almost like inner loops. After completion of the first entity, then followed by second entity, there is some order. There is some order is there, one after another, that is okay. Continuation is there, that is also okay. But remember, first one, second one, there is no relation at all. Inner loops, it looks like inner loops. Some people are asking total 3C1 means 3 ways, 5C1 means 5 ways, totally 50. So 3C1 you know very well. NCR formula everyone know. NCR is nothing but n factorial by n minus r factorial into r factorial. That is NCR formula. Using that formula, 3C1 you find out 3 will come, 5C1 you find out 5 will come, 3 into 5, 15. Some people are asking, sir, where is the 15, sir? I will try to show also where is that 15. In the 3C1, take A. Right, in the 5C1 take 5 possible. So A followed by, you can take here D or E or F or G or H, you can take like this. R, one more, in the 3C1 you can take B also, same 5 possibilities will come. Right, followed by C, followed by again 5 possibilities will come. So like that, like the totally 5 5 5, here 5, here 5, here 5, totally 15. So some people are asking, sir, where is the total? You are saying 15, where 15, sir? Right? So remember, A followed by D is a one way, or A followed by E another way, A followed by F another way, A followed by G another way, A followed by H another way, like that 5 possibilities. Some people are asking, sir, same thing can I do for Bhopal also? Let's check. I think if you observe clearly here 4, right? Let me try here. A1, B1, C1, D1. You can give names whatever. Out of 4, selecting 1, 4C1. Here if you apply here E1, EF, I think F1, G1, H1, EF, GH, I1, J1. Some numbers. So I think 6 ways are there. Out of 6 selecting 1, 6C1. So if you observe here, so to go from Delhi to Bhopal, four possibilities. Out of 4 selecting 1, 4C1. To go from Bhopal to Mumbai, I think 6 things. Out of 6 select 1, 6C1. So 4C1 is 4, 6C1 is 6, 4, 6, 24. Answer is 24. If you see the ways here, if you see the A1 here followed by here 6 possibilities. B1 here followed by here 6 possibilities. C1 followed by at 6 possibilities. Next one, D1 followed by 6 possibilities. So 6 here, 6 here, 6 here, 6 here. Right? 4, 6, 24. 24 ways are there. I'm feeling that everyone is comfortable. Are you comfortable with the product rule? Are you comfortable with the product rule? Are you comfortable with the product rule? Please verify one time. Please, right? Please, right? Please identify once. Are you comfortable here? Are you comfortable here? Right? So please be careful. Topic name is permutations and combinations. Right? Date is 8/1/26. And one more important thing is this course is meant for 2027 people, 28 people. Remember everyone. 27 people, 28 people. This course. Topic is right. Subject is discrete mathematics, permutations and combinations. Right. So the right first topic in the permutations and combinations is product rule and sum rule. First chapter is going, first topic in the permutations and combinations is product rule and sum rule. So please careful. It's very difficult. Sir, can I apply? Can I do computer science without using brain? Impossible. Sir, when to apply product rule? You have to use common sense carefully. See, Delhi to Bangalore and Bangalore to Mumbai, no relation at all. Delhi to Bangalore, 3 ways. Bangalore to Mumbai, 5 ways. Those 5 ways and these 3 ways, no relation at all. But to complete the task, both the things you have to finish. There is a order. First to do Delhi to Bangalore, then followed by Bangalore to Mumbai. Right? One after another, but there is no relation at all. One after another. It is something like, if I want to say programming terminology, inner loops. I loop inside J loop. I loop is there, inside that there is a loop, J loop, inner loop. Each I value, J value. In the similar way, A fix, right, followed by 5 ways. B fix first, followed by 5 ways. Totally 15 ways. Similarly, Delhi to Mumbai via Bhopal. There is a one more. Okay, I feel people are comfortable. I feel people are comfortable. Please be careful. And one more, I don't know whether you know this or not. Let me check here. I don't know whether you know this or not. Let me check here. Note everyone. NCR is equal to NC, N minus R. There is a one formula. If anyone don't know, please be careful. It's a note. NCR is equal to NC N minus R. Some people are asking, sir, how, sir? Can you see this? How? You may say that, sir, how, sir? Can you see this one? That means N factorial by N minus, careful everyone, NCR is equal to NC N minus R. If you want to know how, you can see this. N factorial by N minus R factorial. R factorial. This is the formula. So if you see the right hand side, N factorial by N minus R plus what is there? N minus R there. N minus R. And R factorial. N minus R factorial. So if you observe clearly, N factorial by N cancel, N cancel. Minus of minus R becomes R. So it will become, if you observe clearly, R factorial into N minus R factorial. Remember, multiplication will satisfy commutative property. N minus R factorial into R factorial, it is equal to R factorial into N minus R factorial. So both are same. So NCR is equal to NC N minus R. Please remember. If anyone don't know, please remember. NCR is equal to NC N minus R. Please remember this. I'm expecting answer from everyone. NCR is equal to NC N minus R. Please remember. So both are mathematically, both are same. If you see below in this formula, if you see the second part, below part, if you observe, right, A into B is equal to B into A. That is the reason both are equal. So remember this note. Remember this note if anyone don't know. Remember this note if anyone don't know. It's a note 1. It's a note 1. Remember this one if anyone don't know. Let's see the one more note I want to say to you. One more note I want to say to you. Please listen. Please listen this. Note 2. See this also. See this also. Careful everyone. Careful everyone. Everyone careful. A, B, C, there are 3. A, B, C, there are 3. Out of 3, let me write now. Out of 3, select, out of 3, select 2. Out of 3, select 2. Remember, there are, right, A, B, C, careful. There are 3 elements, A, B, C, right? Out of these 3, select 2. That is my requirement. Out of these 3, select 2. So, if you select out of 3, select 2, right? People will say that out of 3, select 2, 3C2. Which is nothing but 3C2 is nothing but, remember, 3C2 is nothing but 3 factorial by 3 minus 2 factorial. 3 minus 2 factorial into 2 factorial, which is nothing but 3 factorial by 1 factorial into 2 factorial, which is nothing but 3 into 2 factorial by 1 factorial means 1 only, 2 factorial. 2 factorial cancel. Everyone know 3. Only for namesake I am saying, remember, I have 3 people. Out of 3, I want to select 2. Out of 3, selecting 2, 3C2 means 3. Some people are asking, sir, what are those? Observe everyone. What are those? Sir, out of 3, you are selecting 2. What are those? Remember? So, one possibility is AB. One more possibility is BC. One more possibility is AC. These are the 3 possibilities. Out of 3, selecting 2. 3C2. 3C2. Right? Out of n, listen that this is n. Out of n, selecting R, which is, right, NCR. So these are 3. But remember everyone. Be careful this part. Be careful this part. Be careful this part. Understand everyone. Be careful this part. See this one. 1, 2, 3. 1, 2, 3. Careful. 1, 2, 3 numbers. From these 3 numbers, understand. From these 3 numbers, how many 2-digit numbers possible? Careful, it is a very, very important one. Right? Out of this one, out of 1, 2, 3, out of 3 digits, 1, 2, 3, how many 2-digit numbers possible? This is the question. Understand here. 3-digit number. Out of these 3 people, how many 2-digit numbers possible? Remember everyone. Remember, out of 3, how many 2-digit number possible? It is nothing but 3p2. 3p2. What is the 3p2? 3 factorial by 3 minus 2 factorial, which is nothing but 3 factorial by 1 factorial, which is nothing but 3 factorial, which is nothing but 6. Some people are asking, sir, what are those? How can you say 6, sir? Can you see this? Can you see this one? Can you see this one? Out of, right, listen everyone now. Out of 3 digits, from 3 digits, means from n digits, how many 2-digit numbers possible? How many r digit numbers possible? Out of n digits, how many, right? How many r digit numbers possible? So 3p2, which is nothing but npr, Some people are asking, sir, what are those? How can you say 6, sir? Can you see this one? 1, 2 is 1 digit. Sorry, 1, 2, 2-digit number. 1, 3, one more 2-digit number. Next one, right? See this one. 2, 3, 2-digit number. 2, 1, one more 2-digit number. Next one. 3, 1, 2-digit number. 3, 2, 3, 2. And one more thing is, remember how many, careful everyone, how many, right, 2-digit numbers possible without repetition, repetition not allowed, 1, 1 not allowed, 2, 2 not allowed, without repetition. Same number you cannot take. How many 2-digit numbers possible from the 3 digits? How many 2-digit numbers possible? Careful everyone. How many 2-digit numbers possible? How many 2-digit numbers possible? Please try to understand. Without repetition. Without repetition. Without repetition. Same number you cannot take again. Same number you cannot take again without repetition. So these are the 6 numbers. So what I mean to say is, can you understand everyone? Can you understand everyone? I want to say one important story here. Can you understand here? Listen, can you understand here? In the above, if you observe, AB if you take, BA you cannot take. But here you can take. So when you feel that order is important, see, 1, 2 you taken, 2, 1 also you taken. See, order also important. 1, 2 different, 2, 1 different. When you feel that order also important, then go to permutations. Order also important, go to permutations. Order is not important. 1, 2, 2, 1, both same. Then go to combinations. Remember, in the combinations, order is not important. BC and CB both are same. You cannot count twice. AC and CA both are same. You cannot count twice. Right? But in the case of permutations, right, order also important. 1, 2, 2, 1 different. 1, 2, 2, 1 different. Some people are asking, sir, when I go to permutations, remember permutations are nothing but combinations only. But in the case of permutations, order also important. When you feel, oh, order important, then go to permutations. Oh, order not important. Order not important. 1, 2, 2, 1 both are same. Then go for combinations. Out of 3, selecting 2. Out of 3, selecting 2. Remember, without repetition. In both the cases, without repetition. Out of 3, selecting 2. Without repetition. In both the cases, without repetition. Out of 3, selecting 2. How many? 3C2. Right? 3C2. Order important. Order important. It is not 3C2. It is a 3P2. Order important. It is a 3P2. Order not important. It is a 3C2. So please careful. There is some difference. Some people are asking, what is the difference? See, 3 factorial by 3 minus 2 factorial into 2 factorial. Here extra there. See this one. In the case of NCR, here extra will be there. Extra below. Because of below extra, right? Below extra, less value will come. In the case of combination, you will see less value. In the case of combinations, you will see less value. So some people are asking, sir, how to solve this one? Nothing. Can you see this? Everyone observe. Everyone observe. Everyone observe. NCR. NPR. Careful. If you observe clearly, n factorial by n minus r factorial into r factorial. If you see the NPR, n factorial by n minus r factorial. So if you observe clearly, which one is bigger? NPR is bigger because below, right? Above both are same. Above both are same if you observe. But below, if you observe, in the NCR, there is some extra entity. Extra entity is there. Right? In the above, right? In the below, if you see some extra entity, so that is the reason NCR is small number. NPR is big number. NPR is big number. So how many times bigger one is? Remember everyone. Remember everyone. After getting the NCR, multiply by R factorial. Then it will become NPR. First find out NCR, afterwards multiply by R factorial. Then you will get the NPR. The relation between both of them is NCR into R factorial. It will become NPR. So I will write that also. Please be careful. Be careful. I am writing that particular one. So let me write now. Everyone observe. NCR into R factorial is equal to NPR. Because NCR is small number. If you multiply by R factorial, you will get NPR. Some people are asking, sir, when I go to NPR, sir, order is important. Go to NPR. Order not important. Go for NCR. Everyone know this. Just I am saying only casually. Everyone know this. If you do some problems of practice, you will get the answer. Practice some problems, you will get the answer. Practice some problem, you will get the answer. No, it is not revision. Right? So if you think that, see this one. If you think that order is important, if you feel order important, see there here. See this one. How many two-digit numbers possible from 3 digits? Without repetition, how many two-digit numbers possible from the 3 digits? So remember, 1, 2, 2, 1 different. If you feel that order changes, right? Order changes, it is also included. 1, 2 included, 2, 1 also included. Order important. Oh, then go for the permutations. Order not important. A, B, B, A same. Then go for the combinations. Go for the, you should know the difference when to apply NCR, when to apply NPR. You should know the difference. What is the difference between these two? NPR is bigger. Why? Repetition, right? Why? What is the reason? Order changes. Then also you are counting. AB counting, BA counting. AB also counting, BA also counting. Both you are counting. AB, BA, both you are counting. You are counting both. Then that is the reason more is coming. That is the reason more is coming. So how many, right, from after finding NCR, how to count the NPR? NCR into R factorial you do. NCR into R factorial you do, right? Then you will get the NPR. Okay, fine. I think you got some idea, right? But when you do more problems, now you will get more clarity. Let's go to the question number 3. Question number 3 I am writing. Careful everyone. How many ways possible? Try this also. How many ways possible? How many ways possible to go from Delhi to Mumbai? Delhi to Mumbai. How many ways possible to go from Delhi to Mumbai? How many ways possible to go from Delhi to Mumbai? Understand? How many ways possible to go from Delhi to Mumbai? He didn't mention via Bangalore or Mumbai. He didn't mention. So when you don't mention means both you have to consider. Via Bangalore also you have to consider. Via, right, Bhopal also you have to consider. When you don't mention all the things, you have to take care. How many ways possible to go from Delhi to Mumbai, right? Because if you didn't mention anything, via Bangalore also you have to calculate, via Bhopal also you have to calculate. Can you check here? See this diagram. Go to our actual problem. This is our actual problem. How many ways are there to go from Delhi to Mumbai? Right? Because of you didn't mention, see, only Bangalore, calculate only Bangalore. Only Bhopal, calculate only Bhopal. When you don't mention, you have to calculate both. So let me see this. Let me see this one. How many ways are there? How many ways possible to go from Delhi to Mumbai? So now the answer is, I think there are two parts. Via Bangalore. I'm writing the answer. Can you see the answer? Can you see the answer one time? Can you see the answer one time? See the answer. Via Bangalore. Via Bhopal. If you see the Bangalore, I think 3C1 into, see the Bangalore, I think we are already done. Bangalore, we are already done. 3C1 into 5C1. 3C1 into 5C1. Okay. Which is 15. If you see via Bhopal, I think it is going to be 4C1 into 6C1. Which is going to be 24. Remember, this story different. Paths are entirely different. That path different, this path different. No linking at all. No linking also. At least in the product rule linking is there. In the product rule, at least you will see the linking. First one followed by second one. But here no linking. They are different. Above path, below path, there is no relation at all. There is no relation. At least previously linking there. Delhi to Bangalore. Bangalore to Mumbai. Let's wait. I think phone call came. Just wait 1 minute. Just wait 1 minute. Yeah. Thanks everyone. So remember, there is no relation at all. Via Bangalore is different. Via Bhopal, no linking. If no linking, how can you do the multiplication? What is the meaning of multiplication? Linking is there. Right? First step followed by second step. Linking there. Nested loop, something like nested for loops. I loop inside J loop. But here there is no relation. It is something like I loop, not inside J loop. I loop is first one loop, I loop. Next loop is J loop, not inner. It is something like not inner loop. Then you have to add. This is called summation rule. This is called summation rule. So 15 plus 24, which is going to be 39. This is going to be sum rule. It is very difficult to by heart. Don't try to by heart. Try to understand, try to apply common sense. You will be all right. Sir, how I don't know, sir, how to apply. Even I also don't know. I also don't know how to apply common sense. When you practice, you will get. When you practice, you will get. Are you getting? All are human beings only, right? All are human beings only, right? So, you have to apply common sense. All are human beings. You are a human being. I am also a human being. So you cannot see this one. You cannot. This is called common sense. Where to apply some rule. Where to apply product rule. How you know? Linking there. Linking. First step followed by second step. Continuation. Continuation. Product rule. Not continuation. Individual. Individual. There is no linking at all. There is no relation. Right? A and B, no relation. So plus rule. A followed by B. Oh, product rule. A followed by B. Product rule. A is one rule, B is one rule, no relation. A plus B. A followed by B. Oh, product rule. So like that, when you do few problems, practice you will get. In this in today's class, I explained few things. What is sum rule? What is the product rule? Next one, what is the NCR? What is the NPR? Both are for selections only. NCR also for selection, NPR also selection. But remember, in the NPR, order also important. A, B, B, A counted 2. But in the combinations, A, B, B, A, 2 people, A, B, B, A. So 1 person only. Whether you take Ajay, Vijay or Vijay, Ajay, at the end of the day, 2 people, Ajay, Vijay, order doesn't matter. If you feel that order matter, go for the permutations. If you feel that order doesn't matter, go to the combinations. So I hope you got it. In today's class, we done the product rule and sum rule. I think I given 3 problems. 3 problems I explained. 3 problems I explained. In tomorrow's class, because I have another class. In tomorrow's class, sir, anybody watching here giving GATE 2026? It is not for GATE 2026. Because it will waste your time. 2026 people don't watch this. It is not for 2026 people, it is the 2027-28. It will waste your time. If you are a 2026 person, please don't watch this. Anyhow, today's class time is over. Tomorrow's class we'll meet. We will meet tomorrow's class. Thanks everyone. Thank you so much. Thanks everyone. We'll meet in tomorrow's class. Bye. Bye everyone. In tomorrow's class, we will come up with one more model and few more problems. One more model and few more problems we will try in tomorrow's class. In tomorrow's class, we will see one more model and few more problems. Thanks everyone, and and good night. And one more thing I want to say to you, there is a 60% offer going on for the 2027 GATE examination or 28 GATE examination. So those people who want to join, they can join. Yeah, thank you. Good night. Good night, everyone. Good night.